Hello class of 2018. Today we are looking at finding the mean or expected value, and the median of a continuous probability distribution. Some basic definitions. For a continuous random variable x with probability density function f, the mean or expected value is given by the integral from the endpoints of x times f of x. The expected value, yes, I picked up the typo, of g of x is given by e of g of x, and it's basically replacing x's with g of x, and the same integral process applies. The median or the 50th percentile is the value of m such that the integral from the left to m of f of x is equal to half, so this diagram here. Or you could go from m itself to the right hand side and you'd find the integral equals half. So that would correspond to this side of the picture here, if I shade it in with blue. If you're using a CAS, you can just solve for m where you can plug that in and it should work it out for you. I'm going to do things by hand though. So here we have a probability density function given as 4x cubed from 0 to 1, and you're asked to find the expected value of x first, then the expected value of x squared, then the expected value of e to the power of x. Now it looks freaky, but actually it's not that crazy. You're just replacing x's with these functions one at a time. So we'll start with a and then we'll go to b and c. Now if we have a, the expected value of x is equal to the integral from start to finish of x times f of x dx, which is the integral of 0 to 1 of 4x cubed dx. Sorry, that should be x to the power of 4 dx. And if you integrate that, you get x to the power of 5 over 5 from 0 to 1. I can take out the common factors, 4/5, giving me 1 to the power of 5 minus 0 to the power of 5, giving me an answer of 4/5. Now for part B, we do the expected value of x squared, which is the integral from start to finish of x squared times f of x. That should be an x cubed dx. So that gives us the integral of 4x to the power of 5. My x's leave a little bit to be desired, sorry about that. And so if we have that as an anti-differentiation, we add 1, divide by the new power, go from 1 to 0. Then we can simplify this by making it 2/3, make that a common factor at the front, which gives us 1 to the power of 6 minus 0 to the power of 6, which is also going to give us 2/3. And the lucky last one is part C, where we have the expected value of e to the x, which is going to be the integral from start to finish of 0 to 1 of e to the x times 4x cubed dx. Now this function is actually beyond the scope of methods by hand, so I'd plug it into my calculator, and the answer I get from the calculator is negative 8e minus 3, which if I control enter, I get a funky number, 2.25375, but I'm not freaking out because it's an expected value and there are no limits on expected values. Unlike probabilities, which have to be between 0 and 1, expected values can be anything you like. So here we're going to find the median for this probability density function. So we can choose to solve for m where the integral from 0 to m of x on 32 dx equals 1/2. Or you could have gone the other way. You could have gone from m to 8 of x on 32 dx equals half. Alright, so you can do this by calculator or by hand. I'm going to show you how to do it by hand with the first one. So if you integrate x on 32, you get x squared on 2 times 32 from m to 0 equaling half. Then I can take this out as a common factor, 1 on 64 of x squared x squared from m to 0 equals a half. Then I have 1 on 64 times m squared minus 0 squared equals half. Therefore, 1 on 64 m squared is half. Therefore, m squared is 64 on 2, where it equals 32. So m could be plus or minus the square root of 32, but you only take the positive, not the negative, because m has to be between 0 and 8. Now, square root of 32 can be simplified to 4 root 2. So therefore, that's your m value there.